as we continue on the theme of innovation, it's my pleasure to introduce the moderator of the next panel, David Rotman. And I think David, being the moderator, is a brilliant choice because he's been writing about the intersection of innovation, technology, and society for a long time. He's currently the editor at large of the MIT Technology Review magazine. And if you have had any interest in this field for a while, you probably have run into one of his articles. And one that comes to mind particularly, he wrote in 2011, which was entitled, Will We Be Able to Build the Next Breakthroughs? Build Tomorrow's Breakthroughs, where he talks about how manufacturing is critical for the country's economy and the future of innovation. So with that, David, thank you and welcome.
Thank you so much for that kind introduction. And welcome to this next session, which I'm really excited about, the next gen AI for design and manufacturing. Really, we're going to look at how generative AI, which we've all been hearing so much about, is going to change design and manufacturing. And as you just heard, I've been writing about manufacturing innovation for a long time, but I think generative AI in the last 2 years is changing everything. And I started being a bit skeptical when I started reporting on this, on generative AI, but now I'm not. It is changing everything, and people are trying to learn what it means. And so we have a great panel that's going to tell us what generative AI means for design and manufacturing. And we're going to hear from some very different perspectives. 3 great speakers, from research to the business side to the details of how to make AI more relevant. So Julie Shaw is a professor of aeronautics and astronautics here at MIT. She leads an interactive robotics group at CSAIL. And she's also a co-leader of a Work of the Future initiative here at MIT. So jobs, and she'll tell us about jobs. Fayez Ahmed is assistant professor of mechanical engineering here at MIT. He leads a design, computation, and digital engineering lab. And he's going to explain to us what that means, what that lab does. And Jeff Kinder is an executive VP at Autodesk. He heads strategy and execution at Autodesk design and manufacturing portfolio. So we'll hear the business side and what the customers want. So please join us, and then we'll have some questions. You were all set?
I hope so.
We'll see. I think we're all set. I'm going to each ask you a couple of questions. Fayez, why don't you start? I just sort of give us a general sense of how generative AI will change design and manufacturing. Big question. I'm particularly interested in how it helps the transition from design to manufacturing.
Yeah, so first I think one thing, because generative AI is a relatively new field, let's start with describing what is generative AI. And generative AI is one of the AI methods. And the basic fundamentals for it is that it learns from a lot of data, how data is distributed, the distribution of the data. And then once it has learned, then it can generate new data, which we may or may not have seen before. Now, we have had generative AI for a while, like mixture of Gaussian models, topic models, and so on. But what has changed recently is that these models have become extremely powerful. Like, I'm imagining most of the room would have heard this obscure tool called ChatGPT, right? So now a lot more people are using it, and these tools are actually becoming very powerful. And language is what we hear the most about, but I think for design and manufacturing, going back to your question, we are seeing more and more multimodal models come, which can work with different modalities, and that's where it really becomes powerful for design and manufacturing. In design, you come up with a plan to create a product, and in manufacturing, you actually make that product. And essentially, what generative AI can help is each step of that process, either coming up with better ideas, coming up with ideas that can actually be manufactured, or helping people come up with those designs, use tools, and so on. So I think, yeah, there is lot of changes that we'll see in the near future on how we think about designing and manufacturing products. Also, there is a lot of challenges, and that's something which as at MIT, we think a lot about what are the challenges for generative AI and what are the things we need to think about for engineering in the next decade.
And I want to come back to that because I know you've written on sort of a call for a next version of generative AI tailored to manufacturing. And I want to get to that in a second. But also I want to ask Jeff, just sort of tell us what your customers of Autodesk are looking for and what their challenges are when you begin talking to them about generative AI.
Sure. I have the pleasure of meeting with lots of customers. In fact, I was just a couple weeks ago, I was in India, and then Japan, and then Korea, so I get to hear firsthand. What customers say to us around the globe is pretty consistent. They want more creativity or innovation. They want better productivity, and they look a lot at efficiency and flexibility. How can they be more flexible? How can they be more efficient? Because they are in highly competitive markets, and all of those things matter. And by the way, they're doing this all in the midst of a rapidly changing landscape around them: supply chain disruptions, labor shortages or skilled labor shortages, geopolitical risks, inflation. So they wrestle with all of these things kind of in context. So they're looking for, what are the ways that AI, they're all excited by AI, it's very exciting to them, and they're looking for ways that can help address that broad set of needs. So it's, when we think about AI, after listening to customers, we try to think about how do we approach this in a broad way? How do we not just zero in on one thing, like just automation to replace things? How do we think, broadly? And we create a framework around augment, automate, and analyze. It's all of those things. How can we augment creativity? How can we automate tasks that feel lower value added? And I'll give you an example in a second, something we've already rolled out. And how do we use AI to provide faster analysis of what we might be seeing in a product or in a manufacturing process? So we try to solve those specific problems. They're looking for help in those areas. So, for example, we rolled out something called automated drawings using AI. And it's basically taking a 3D model and then automatically generating the 2D drawing in dimensions, which is required almost everywhere in all of our customers. But it is a low value added task. So we have skilled engineers that spend, by our research, up to 40% of their time doing these rote tasks. And if we could free up their time to think about other problems and solve other problems, that's a huge unlock for customers. So that's the type of thing. They're excited. They tend to think in terms of, what can you solve for me today? They don't always go to the, oh my God, the world's going to be run by machines. What does this fully autonomous world look like? They're like, they have real problems right in front of them now, and they wonder how AI can help them solve that.
I think that's so interesting. When we think about generative AI, we hear about all these sort of amazing things, but sometimes the most practical uses are just sort of mundane, but speeding up the work, stuff that people don't want to spend a lot of time doing.
Yeah, and augmenting creativity. We bought a company last year that in the automotive sector, it accelerates the process of creating new designs of automotive. A company can upload their library, and then they can draw on this database of 300,000 auto models over time and say, oh, I want to stretch this out. I want to make it more sporty. I want to make it more lengthen the wheelbase. I want to make it stronger. I want to make it an SUV. And it can automatically generate hundreds, thousands, of versions of that faster. So it accelerates, in that case, creativity.
And creativity, right. Julie, I want to ask you, I know most of your research in robotics and human collaboration. I know you work in other areas too, but particularly in that area of how we collaborate with robots, has generative AI changed? How has it changed, and how has it changed how you're thinking about it?
Absolutely. Well, it's quite an exciting time. So, I'm an AI researcher. I run a robotics lab. I joined the Computer Science and Artificial Intelligence Laboratory here as a PhD student back in 2006. So I've been in AI for a while. And, in terms of what we're looking at today versus the technologies that we've developed and matured over the decades to now, there's new possibility in ways that I could not have envisioned at the start. But when we look at manufacturers today and just look at standard industrial robots, 1 in 10 manufacturers has a single robot, and they're very low users of that robot typically. So the cases where we need these systems to work flexibly, where we need to be able to easily reprogram them, to date, for a variety of reasons, the sort of implementation challenges of that have been high to be able to reap the benefits of these technologies. But what's very different about generative AI and very interesting is that automation, but also AI, many of the forms of AI, prior to what we have now with generative AI, has been capable of solving very specific problems and producing high performance in solving those very specific problems. But what you lose from that is flexibility in the tool. And you see a similar phenomena with robotics and automation. You can program it, it performs with high performance, high reliability, but it's relatively inflexible to program. What's very different about generative AI is that, at least to date, what we're looking at, it's a fundamentally different technology in sort of its characteristics. It affords very significant flexibility, but to the extent that you achieve high performance, high reliability, is highly context dependent. And so my colleague Kate Kellogg characterized it as the jagged edge, which is changing on us. And it's very challenging to map right now, where that edge is and where we can expect very high performance in the ways we've traditionally utilized and implemented automation and AI technologies. But in my own lab, and looking at sort of ease of use, ease of programming of robot systems, I personally, I'm excited for my colleagues that are looking at sort of end-to-end approaches of generative AI. You tell the robot what you want it to do, and it just does it. But there's an avenue towards pushing, to the extent possible, what a new technology is capable of doing. But what we see in our lab, and also what we see in ECHO when working with a few of the companies in our working group on generative AI, is that there's very exciting use cases where you think really much more surgically about the places that this limited flexibility has really been the critical bottleneck, and develop and vector the technology to solve that critical bottleneck, and then it can be truly transformative. So I think it's a whole new world, but maybe not in the sense that it's magic beans and it's going to do all the things we need it to do. So the engineering and implementation aspects are critically important, but with that mindset, I think it changes the game fundamentally.
People often know one of the things about ChatGPT was how accessible it is, how easy it is for a non-expert to use. Does that translate into what you're thinking about, how workers can collaborate with robots and sort of natural language, just talking to them?
Yes, yeah. So natural language as a modality of communication is very, very natural to us as humans. But what I can tell you is that the devil is in the details. Much of what we convey is highly underspecified and highly context dependent, requiring prior expertise, training, judgment in order to be able to make use of it in that context. In fact, there's very, very good studies that have come out in the last few years that the ways we thought natural language, even a robot or an automation system expressing back to us in natural language, which underlying is a formal logic representation, but nonetheless explaining the formal logic representation of how it acts in natural language, we thought that would be an interpretable way for a person to build a mental model of a system's behavior. And it is not. It's on its own, it is wholly insufficient in building a person's mental model of how a system will act or behave. So that just highlights for us the very complex way that we as humans sort of build that understanding and capability, and the engineering endeavor in automation to building that reliability and performance that unfortunately I think via the natural language interface is not sufficient.
Interesting.
If I could add something onto that, one of the things that we're working on and doing some research in ourselves is how can we use natural language to help set up a problem and then pass it on to more deterministic algorithms and solutions that'll be more precise. Because that is a huge problem. Like the systems are not, the current ChatGPT or large language models, multimodal models are not specific enough or precise enough, but sometimes they're hard to start. And so if we can actually use these breakthroughs to help, get into a more deterministic, specific system or result, that would be a benefit.
Interesting. Interesting. I know you worked on a paper, you wrote a paper recently called Next Gen AI, which, as I read it, you really were calling for a next generation of AI that would be more tailored, more useful for manufacturing people.
Yep.
Can you tell us what that would look like, and also sort of what were the shortcomings of existing technology that you're trying to overcome with this next version?
Yeah, so I mean, this particular paper, From Automation to Augmentation, this was a collaboration between my group, Professor John Hart, and our colleagues from the economics department. And in this work, we actually questioned how current Gen AI is and what are the current gaps. And I would like to break it down into some parts. I think one general gap is precision, which was just mentioned. There are issues around modality, right? You cannot, if you're working with design and manufacturing, your data is not just text. Your data is not just images, right? So we started identifying some of these gaps, and multimodality, precision, understanding some of these requirements were some of the gaps we identified. And then we prescribed some suggestions on, if you're thinking about creating the next gen AI solutions, what are the things that you should consider? And it's a long paper, so there are lots of things. I would not go through everything. But I think there's one key aspect which I want to bring up. So there is the model development part, which is like, can we actually make Gen AI models which are more precise? Maybe they should be able to access engineering tools. But the key aspect is data. And that's the conversation we should be having front and center instead of the conversation around Gen AI. Your Gen AI is both limited by its data and its power is in its data. The reason it's so powerful is because it has learned from the internet data. The reason it's not so powerful, like we looked up, there is a very popular open source data set of books. Guess how many manufacturing books are there? 0. So
Amazing.
This is a model which has learned from Harry Potter. And it can learn so much about like chemistry and mechanical engineering from these books. It cannot do very well on engineering data sets, engineering problems. So if you're thinking about next gen AI, I think the data set collection usage is a big part of it. And then there are other parts around how we build this, how do we focus on augmenting instead of just automating.
Is the model, the existing architecture of the existing models, is that okay? Or is this a matter of feeding it into more relevant data? Or is it a bigger effort than that?
So again, I think the current model has a lot of benefits, but it depends. In future, we'll see more and more truly multimodal models. Right now, we don't have that. We have sequence-based models. So 3D language, like different forms of 3D, different forms of modality will come in, and different architectures will start talking to each other. So I don't think there's a bullet, like there's one solution on like transformers are the right architecture. I don't think that will be the case.
Jeff, we just talking about data. What is your customers? They must, it's always a challenge for companies to come up with data, I think. But tell us, what are the challenges they're facing? How do you help them sort of with those challenges in terms of collecting the relevant data, really, I think, is a point.
Yeah, it's interesting. It's data is it's critical to Faiz's point. Our industry and lots of industries grew up this way with point solutions deployed point software solutions deployed on premise. That's really hard to train an AI model with that data because by definition it's not end to end, so it's not design and make, and it's also hard to access when it's on premise. So it's funny, before I ever even joined Autodesk, Fusion was created 10 years ago partly to address that problem, which was design and make data together in the cloud and connecting all those steps in the process. But that's, I think, what our entire industry is going to need to do, and other industries will need too, is to how do you pull data out of on-premise, put it into the cloud so it can be trained, and then start breaking up into granular components that encompass the end-to-end. We're not there yet, and that's what's going to take a while to then train those foundational models in manufacturing. The other piece is, areas like IoT and connectivity on the shop floor, they're just not as mature as they need to be. We're making investments, our peers are making investments in those areas to actually collect more of that data, because all that data is going to be relevant. The other interesting thing on data we hear from customers a lot is the model data is their IP. And so they're very protective of their IP. And they're looking for trusted partners that can help them and make sure that they get the benefits of AI, but they don't lose their IP or compromise their IP. It's very top of mind. I mean, they want things like that. Like, when they think about IP, if you can automate their drawings, like the example I gave earlier, that's great. That's like spell check or grammar check, right? You're taking a task away. You're not giving away my IP, but it's bringing value. So they look for some things like that and other ways you'll be able to create it. They're worried, I will say. I mean, they've seen what's happened in the last 20, 25 years with other content providers, say in media, who made their content available. And 25 years later, the rewards didn't go to those content providers. They went to other large players. So they're nervous when they see the hyperscalers in this space, some of the big cloud and compute companies. They're like, well, we can't cede all of this IP and the value to those companies.
Interesting. So kind of the dilemma, we need the data to better train the models, and yet the data is the lifeblood of these companies. Before I leave that though, it must be daunting for many of these companies. You're telling them they really have to rethink their businesses, collect more data. Is it daunting for these companies in terms of investment, in terms of the time required?
It is. I mean, I say this all the time. Manufacturers are not afraid of technology, but switching costs are high. They train, they set up machines, they train their workforce, they build processes. It is daunting, but it's needed, and they can't think about it in isolation. I know, Julie, you've actually talked about this. They have to think about the whole system. Like, they need to rethink their processes, the machines they use, the people that they have, and how those are going to change to really take advantage, going forward. And look, the leaders will do that in the space. And if they don't do that, it's risky.
And we haven't even talked about the sort of reliability of the AI, of not making errors. But Julie, we've been talking a lot about sort of the business perspective. I want to switch a little bit to the workers' perspective and just remind people, you co-lead the Work of the Future initiative here at MIT, which is doing amazing work about how technology is changing the workforce and jobs. So my question is, when you think about how does this affect workers, how does it affect jobs, how will it affect going forward?
Yes, absolutely. I guess building on the thread of the importance of data, and then segueing into this topic, with the working group, one of the interesting questions that came to us was, is generative AI a way to leapfrog potentially over, not for a variety of reasons, not having made the investments and having the pipeline, the data to be able to work with? Is this something where these companies are training across these broad sources of data? They have that covered. Now we have a more capable capability that we can use in our manufacturing setting or in other settings as well. And one interesting observation is the jury might still be out on that for the long term, but many of the very exciting, rapidly sort of scaled use cases are in firms that made decades-long investments in data and digital infrastructure. And then in a few ways, we're able to really unlock that investment with generative AI. And that's maybe not necessarily a happy view for a firm that would be looking to leverage this technology in a different way than the prior sort of investment pathway. I think a positive of it from what we've seen with a few of our case studies is that it opens up new opportunities to be able to bring those with domain expertise closer to sort of the software and sort of digital enhancement of processes within a firm. So, as an example, leveraging sort of more natural language interfaces, it allows those that were potentially, previously manually driving, their roles to be able to translate knowledge and importantly vet knowledge that had been sort of cataloged and was used in sort of training or other tools in a way to increase its quality so that it could be used operationally sort of in real time and leveraged. So for example, in call centers, this is one of the things that we've seen. Imagine troubleshooting a complex piece of technology and you call in and there's a repository of typical sort of troubleshooting techniques or underlying causes. And actually, the more natural interface enable for the ability for those with the domain expertise to be able to directly access that content and refine that content provides new enabling capabilities for improving the quality of the work from the worker's perspective and also quantitative performance for the company. And so we haven't seen sort of wholesale supplanting of jobs in the way that so many talk about might be coming with this technology. But I would even say the flip side of it, for the level of investment that society is putting into this, and it is a very significant investment, like we better be able to see a return on this investment in a way that's very different than the return on investment and sort of the challenges we've seen in implementing and scaling more traditional forms of automation and even AI. And so, part of that challenge is that if generative AI used in a particular way can free up 20% of a person's role, then how does a firm recoup that investment? It requires role reconfiguration. It requires other changes within the firm and sort of a roadmap over time to being able to realize that benefit. But what we do see is real opportunities for upskilling concurrently with introducing of these new technologies and role reconfiguration. There's a history in robotics and manufacturing and in automation that shows that that's possible. And that's something that we have to vector for and strive for here and to make happen if we want to see those sort of broader societal benefits for the increased implementation of generative AI.
Interesting. I think one of the more encouraging, in my mind, is some of the recent research that shows generative AI is particularly helpful for less experienced and less skilled workers, bringing them up to speed, basically. Not making them superstars, but bringing them up to speed.
Absolutely.
Okay.
Yeah, there are cases of this, in the early studies, which is very exciting.
Yeah. I wanted to sort of take some questions from the audience. So why don't you get them set? And I have a few more questions for all the group. One very general question, but one I'm very interested in, is the sort of connection between innovation and design and manufacturing. And so I'm interested in how generative AI can help think about innovation in the space of manufacturing. You're thinking about new manufacturing technology, and I don't know if this is I imagine this is a question you all have thought about.
Definitely.
You're a researcher, Fayez.
Yes.
How does this help you think about innovation in the manufacturing space?
Yeah, so this is a fascinating problem because first of all, when you think about innovation, I think there are two critical components of innovation, and most of the times people think only about the second component. The first component is that the thing that we innovate on should work. It should be high performant. It should actually provide useful value to whichever domain it is, whether it's design or manufacturing or other domains. And the second is it should be novel. which is that it should be different from things that we have already seen. What we are seeing a lot with current generative AI is that it is coming up with unique and novel things. We are still lacking in areas where we want to combine it with physics and engineering performance and the real world aspects of what people want. There is a lot of work which is ongoing around this, but that's a key factor on combining performance, augmented generative AI, which can come up with things that are not in its data set. Not just, and sometimes again, creativity or innovation, you want to interpolate. Someone has invented this and this, you come up with something which combines those two. And I think these models can really excel at that part. The second part of creativity is you can extrapolate. We have only seen these things, can we go outside? And that's relatively hard. Our research, the way we have found where it works well is to combine generative AI models with engineering optimization, decades of research around engineering optimization, which can do precise search, but is not very good at like understanding the design space. So what we have found is that combination helps in actually going outside and extrapolating. So yeah, this is a fascinating area, and I'm waiting for the time when we have a lot of patents coming out of our generative AI models. So,
Julia, has it affected how you actually do your research with robotics?
Oh, definitely. From when I participated in the task force on the work of the future, my students and researchers conducted site visits and interviews of manufacturers, OEMs, suppliers in Europe, in the US, and what came back from that were sort of insights that's entirely changed the course of our lab's research. And one of the quotes from that was the best examples of successful automation, advanced technologies were when shop floor workers worked side by side with engineers to develop and refine those solutions. And so domain expertise is really sort of at the core of success here. But often with the robots, even we develop that are working alongside people, it requires a third party, like an external integrator or even a PhD to be able to set up and configure that system. And the problem is that then you pull away the opportunity for those with the domain expertise to innovate on the shop floor. And so what's very exciting about sort of our early work in utilizing generative AI and sort of pushing accessibility of robot programming is that it really, much like we see in these companies, sort of strategically, surgically using generative AI to unlock a few key bottlenecks can be transformative. From what we're seeing so far from my lab, from those of my colleagues in robotics, is it's equally transformative in robotics. So it's really a very exciting time, and I think could be a whole new moment for use of robotics and automation for especially SMEs, high mix, low volume.
I promised the audience some questions. Sir, you want to go?
Yeah, you'd mentioned that models are trained on Harry Potter and not manufacturing, but also touched on that companies are really concerned about IP. And so I was wondering, in your opinion, what are some ways that we can open source manufacturing information to create these informed data models while also still protecting IP?
Yeah, so glad that you brought this question. I think there is a couple of things which I think are more on the pragmatic side in the short term. So first thing is, if you are a champion in a company and you have data which you think is not of a lot of kind of like IP related issues, you should try to make it public, because those will in general like bring up the field. I do see there are not a lot of incentives for doing this for most companies, right? The second part is, I think synthetic data will become front and center. And there is a lot of value we will be extracting in the next decade out of synthetic data, which is how can we look at a small amount of high quality, like real data, and create more synthetic data, and then essentially train those models, train these models with those. There is also the value that you have these foundation models which are trained on the internet data, and we push the boundaries as much as possible with those, combine them with engineering tools. But then you can take those models and essentially provide a small amount of your own data, which could be in-context learning, fine-tuning. A lot of people are doing different variants of it, where you have your local model and you're using it, which is specialized for your data. So there are different pathways, and I think eventually the solution might be a combination of these.
Jeff, do you want to add any? You mentioned the concern of some of the companies over the
Yeah,
data.
I mean, look, I mean, a lot of our customers are very, very nervous that, that is their secret sauce, so to speak. And now everybody has gets the full benefit of that. I mean, we focus a lot on making sure that, data is ethically kind of pulled, that we have clear kind of contractual agreements in terms of use with our customers, in terms of how we use data. And, ultimately, we spend a lot of time with customers talking about and this is a little bit back even to the last question, what outcomes do they want to achieve, and how can we help them use AI to achieve that outcome? And we try to have an open dialogue with customers on that. I think, to be honest, open source scares them, customers quite a bit. And it's interesting because, our company, we're software developers, so we use open source all the time. But our customers, that's not necessarily the world that they come from, and so there's some education that I think is happening, and also considering that how you protect their work.
So interesting, sir.
So this is the answer I think I'm looking for is going to be a little bit on the philosophical side. Sorry. And a little bit on the practical side as well. Right? So you talk about next generation generative AI and how it can help in the design and build in manufacturing in the United States. And I think about that, and I'm wondering, is this a case of, well, we can do it, but should we do it? And the reason is, in order for the models to work, you have to have huge amounts of data, as the gentleman in the middle mentioned already. And I spend, my life year to year visiting manufacturers all over the United States. And one of the commonalities is they have lots of data, or they're generating lots of data, but they're not capturing any of it, right? And 95+% of manufacturers in the US are small businesses. They are trying to struggle with moving forward in a very competitive environment at a far more fundamental and basic requirement standpoint than being able to leverage a next-gen generative AI model, right? And so when I think of that, when I think of the fact that, the data just doesn't exist or can't be retrieved for the vast majority of manufacturing in the United States to take advantage of, shouldn't we be focusing more on the fundamentals as we talk about advancing manufacturing in the 21st century before we're talking about the moonshot, like the gentleman before mentioned, right? Or might we be getting into a situation, as a previous presenter, he had that incredible model that he put up there and it was great. And I noticed every company involved with MIT that was involved with that model was like a Fortune 500, right? So the benefits are going towards the really large companies, and we start to almost have a disparate gap, right, between the haves and the have-nots when it comes to data and when it comes to the generative AI. And I'd just like you to comment on that.
I think that's such a great question. I'm really looking to see what the answer is.
I can get
Yeah,
started.
take a stab.
Please.
So I think there are different parts of this question, and I like to break it down into each part. So the first question is, should we do it, right? So if someone has used ChatGPT and used it to learn something new, will you live in a world without ChatGPT now? In 2017, I was for the last decade, I've seen how language research has gone. Like NLP, we were using topic models, TF-IDF, and it was people were asking, why are we doing this? And then there was this breakthrough with lots of data. And now there is a lot of value in education. There is a lot of value that is being provided to people who don't have necessarily access to education, for example. Like Khan Academy has a very nice video. So I think for research, we often think far ahead and want to create these tools for the future. The second part of it is, I do agree that the organizations are focusing on their now, right? Like what value they get now. And in the short term, they are already getting some value. Like if people are start using ChatGPT or these type, I think as a design assistant, you can ask questions, and there are some examples of it. We should not stop doing everything else. We should not stop getting like lower cost, better throughput, and so on. But then there is no harm in thinking about what are the other things which these large models can provide in improving your efficiency, and also thinking about, are they helping your bottom line, right? And as the models improve, that will also change. Going back to the third part, I would leave it to other panelists thinking about like the whole, where do the profits go? And in my opinion, I think there is, Gen AI is slightly different, because on one hand, people talk a lot about automation, but in reality, it also democratizes a lot of the fields and reduces the barrier of entry. So I could not write poems. I cannot draw very good art, but now I can actually do a decent job at it. I can write poems about things that I could not write. I'm not trained in that. Similarly, can we think about the same paradigm for our workers, where they could do things which they are not necessarily trained in engineering software, CFD simulations, as a kind of design assistant?
Jeff, could you particularly,
Sure.
I don't mean to cut you off, but I'm particularly interested in the part of the question about the challenge for small companies in collecting and utilizing data.
Yes, we serve a lot of mid-market and small, medium-sized businesses at Autodesk, look, there are lots of advantages to large companies' economies of scale. All kinds of cost and compensation, ability to invest. There are also, by the way, diseconomies of scale. You tend to be a lot slower, and you're not quite as agile to adapt to changing environments around you. I actually think that generative AI is going to mute some of the benefits of scale. Because I think if you can make it accessible, like we're making some of our generative AI capabilities available in our software, they'll be available in there. And so smaller to mid-sized manufacturers can now get almost the wisdom of the crowd from other small manufacturers or large manufacturers. So they're going to get the benefits of training across lots of large customers. It doesn't mitigate all economies of scale and all benefits of being large, but to the extent it's just included in the software that they're already purchasing, and they get this wisdom of the crowd aspect. And you take that in combination with what Julie said earlier about faster training of new workers, maybe availability of some expertise. I think Faiza said like that wasn't available before, that they wouldn't have access to. I actually think that generative AI can help to level the playing field more than it might seem obvious.
We just have 1 minute left, so I'm going to, Julie, leave you with the third part of that question. For manufacturing using generative AI, is that a moonshot? Or is it just a practical next step? Sorry hope I didn't distort your question. Is it a moonshot? Are we, dreaming of a future?
I guess just to come back to something I started with. When I started in AI, I went to an AI conference, and there was a plenary session where the leaders in the field were going to answer the question, "What is AI?" And I was brand new in the field, and I went there, and I was, thank goodness, they're going to tell me what AI is. And then I realized over the course of that session that they were arguing. Like there was no agreement in the field as to what the definition of AI was. And when I talked with my advisor about it, he told me something that has stuck with me forever, which is that it's terrible to be an AI researcher because you're always working on something that almost works. The moment it works, no one calls it AI anymore. So voice recognition into the phone, AI. Google search, AI. So when you look at these surveys, are manufacturers using AI? What do they interpret? Because everybody uses Google search, right? And now everybody uses GPT in some form or another. And so I think the question is not, is this a moonshot? But I think it is very important to ask, with the resources and investments we have, where and under what time horizon can we see the value for that for workers, for firms, it's natural that large firms will have the resources to move and sort of maybe prove out the ways that we can use this. When we looked at challenges of a variety of firms using robotics in manufacturing, the ones that came up in small and medium firms, high mix, low volume, the lack of flexibility, the challenge in reprogramming, the challenge in integrating domain expertise on the shop floor, all of the large firms had those same challenges. And this is a technology that can help address some of those challenges. And they're equal pain points for large firms and small and medium firms. And so I'm very hopeful that this is a technology that will have broad benefits.
That's a great way of leaving it, I think. Thank you all, and thank to the audience for all the great questions. Thank you.